Hey guys. So the last science video we're going to do is about the quote unquote competing theories passage. And it's when you've got, 2 to 4 students or scientists who are debating a scientific topic. And you actually want to approach this one differently than the other passages. There's always going to be one of these in a section. And your job on these is actually to read the passage part first before going to the questions. It's the only passage where you do that. And so here's how you're going to do it. There's always going to be an introduction. And you're going to read the introduction. And as you read the introduction, the key question you're looking for is, what are they debating? What is the debate? So as we read this little, and basically anything that really seems important to telling you what is being debated here, you want to circle and underline. So let's see here. We got biological aging is the process by which the functions within an animal cell gradually decline, causing the cell to age. 4 students each propose an explanation for how this process, how aging occurs. Okay, that's going to be it. That's the debate. The next thing you do is you're going to read the arguments. But in one way, this is from Michael Saros for Love of ACT Science. He makes a great point. You can think of these arguments as if it was a table or graph written in paragraph form. It's kind of true. The other passages have tables and graphs. This one has, a written argument. All right. Another thing to know is that each of the arguments, the students or the scientists' arguments, are structured the same. They're each going to address the same point first. And so as we look at these students, let's look at student 1. Biological aging is caused solely by the reactive oxygen species produced by cellular respiration. Okay. Then let's check out what student 2 says about that. Biological aging is caused solely by the formation of crosslinks. Blah, blah, blah. Student 3, biological aging is caused solely by the DNA damage. So each are going to kind of make an argument about the same topic in the same place. And here's a little bit more what I mean by that. Let's say that the blue is the first point student 1 makes, and then yellow is the second point. They're all sort of going to address the yellow point next. Now, they don't all follow this perfectly, but close enough, and it's a good way to think of it. And then let's just say student 1 has a third point that they make. They're all going to address, we're going to call this the orange argument, third. So they all are going to go blue, yellow, orange. And how you want to read these students is first read the first argument and the first student, and then immediately see, because this is a scientific debate, immediately see what the second student says about that. And then see what the third student says about the exact same point. And then the fourth thing you're going to read, let's say there was just 3 students here, is going to be student 1's second argument. And then you're going to see what student 2 says about that. And then you're going to see what student 3 says about that. So these numbers here are kind of the order in which we're going to read things. I'm probably making it more complicated than it needs to be. But the point is, read all the blue points first. Read what they each say about the first point first. And you're all the while you're underlining and circling for the key points that show where they agree and disagree with each other. And then read all the yellow, kind of the second argument they each make, and see where they agree and disagree with each other. And then read the third argument they make and see where they agree and disagree with each other. And all the while you're circling and underlining the key points that distinguish their arguments. And the other thing you want to do is stereotype. So what I mean by that is hyper oversimplify each argument. And, not relevant to this passage here, but think of it like, all right, yeah, whatever. We'll try it on this one. So student 1 here is the ROS student. Student 2 is the crosslinks one. Student 3 is the DNA damage one. So whenever you get a question about crosslinks, you're going to know it's student 2. Whenever you get a question about DNA damage, you're going to know that you got to go back and look at student 3. So that's how you approach these passages. Go through the intro, underlining and circling what really lays out what the debate is, and go through the students trying to see where do they agree and disagree with each other. And then you're going to get to the questions. Now, the map phrases on these passages are the particular students that we're talking about, a student and a scientist. So if it says based on student two's explanation, you're going to go back and you're going to start looking for your research phrases in student two. And I'll just come back to that stereotyping point. When you hypersimplify in your mind what each of the main thrust of each argument, it's either easier for you to track and distinguish between the arguments and to kind of know which scientist or student to go back and look at based on what the question is saying. One last thing, you want to give this passage probably 2 extra minutes. So I'd say on regular time for ACT science, 5 minutes per passage is great. And then on this competing theories passage, give it 7 minutes. And that should be it. Let me just check my notes. No, that's it. That's everything on these passages. So in the intro, look for really what's being debated. Then as you read the arguments, compare where they agree and disagree. You can go argument by argument as you know that each kind of structurally address the same issue at the same point in each paragraph. And then use the students' names as the map phrases when you get to the questions, and hyper simplify and stereotype the scientists or students in your mind, and then you'll have an easier time tracking them as you answer questions about the debate. So that's it. Good luck.